The overall goal of this nanosponge synthesis technique is to understand and utilize important synthesis parameters for design and control of size and morphology.
This method will help you to produce nanoparticles in precise dimensions and cross-linking densities for drug delivery applications. The main advantage of this technique is that it can be tailored towards different cross-linking densities of these particles and also towards different sizes of these particles. And this is a very important factor in many applications where these particles will be used.
Though this method can provide insight into nanoparticle design through utilizing tailorable synthesis parameters, it can also be applied to other polymer networks such as hydrogels and microparticles.
Remove moisture from a 25 milliliter round bottom flask equipped with a magnetic stir bar as detailed in the text protocol. Once cooled, quickly remove the septum from the round bottom flask and add 2.5 milligrams of 10-triflate to the very bottom of the flask using a spatula. Replace the septum. Sequentially, add 72.6 microliters of 3-methyl-1-butanol via a 100 microliter microsyringe and 1.33 milliliters of anhydrous DCM via a 2 milliliter syringe. Stir the suspension on a magnetic stir plate for 10 minutes. Next, sequentially add 0.48 milliliters of AVL and 1.37 milliliters of VL. Allow the reaction to continue stirring for 18 to 20 hours. Quench the reaction by adding approximately 5 milliliters of methanol. Then, add 100 milligrams of solid support.